Hi guys, so this is question 1 on the Unit 1 Summer 2019 WJC past paper. We're asked to solve the following equations for values of theta between 0 and 360 degrees, and we're told that 3 tan theta plus 2 cos theta equals 0. So this is your classic trig question where you're given two trig functions, and what we're going to aim to do is sub in different trig identities to get them in the same trig function. So we're either going to have sine thetas or cos thetas or tan thetas. That way we can factorize and solve for them. So what we need to do is write down our trig identities. So our trig identities we need to know for this question is tan theta equals sine theta divided by cos theta, so that's our first one. And we know that sine squared theta plus cos squared theta equals positive 1. Okay, so there are two trig identities, really important that we know these. Okay, so what we're going to try and do is plug our trig identities into our equation just to get them into the same trig function. So here we go, we've got tan theta, so what we can do is plug our tan theta equals sine theta over cos theta into as tan theta. So here we go, we're going to have 3 lots of sine theta over cos theta plus 2 cos theta equals 0. Okay, and so the next part I'm going to do is I'm just going to times through by cos theta. That will tidy up our equation quite a bit so that we don't have a fraction. So what we're going to do, we're going to have 3 sine theta. Our cos theta over cos theta will cancel out, and then we're going to have plus 2 cos squared theta, and all that will equal 0. Okay, so now I'm going to use my second trig function. My sine squared theta plus cos squared theta equals 1. Firstly, I'm going to have to rearrange this in terms of cos squared theta. So I'm going to have to minus sine squared theta from both sides to rearrange this to get cos squared theta in terms of cos squared theta. So I'm going to have cos squared theta equals 1 minus sine squared theta. Great. So now I can put that into my equation, and I'll have 3 sine theta plus 2 brackets, so 1 minus sine squared theta equals 0. Okay, so I now expanded out that bracket. I'll have 3 sine theta plus 2 minus 2 sine squared theta equals 0. So right now I can see that this is going to be a quadratic formula, so quadratic equation, sorry. So because we have power 2 sine and then power 1 and power 0, so I can make this more visible by changing by letting x equals sine theta. So by doing this, I have 3x plus 2 minus 2x squared equals 0. And yeah, so we can see that we've got x squared, we've got x, and we've got integer. So what we can now do is write it, so when we normally write quadratic equations, we like to write it as in terms of ax squared plus bx plus c equals 0. So I'm just going to move the terms in this equation. So I'll have minus 2x squared plus 3x plus 2 equals 0. Okay, and the last thing I'm going to do to this equation now is times through by minus 1. All that does is swap all our signs around. So I want this, our first term, our x squared term, to be positive. We have a negative right now, and I want that to be positive just to make my life a little bit easier. So I'll have 2x squared minus 3x minus 2 equals 0. Okay. And now I can factorize it. So factorising is a very important part of A-level maths. I think you'll use it in majority of the questions. You need to be able to do it for different coefficients of x squared. So here I know I'm going to have 2x, x equals 0. And now I'm going to have to find integers little a and little b. So I'll put plus a plus b. We're going to make our two equations, and we're going to find numbers for a and b that satisfy both our equations. So we know this minus 2 is a times b equals minus 2. Oh. And so our second useful number is here. So this minus 3, we get minus 3 when 2 times b. So we've got 2b plus a equals minus 3. Okay, so now I can look and try and solve these two equations. So I know because I have a minus here for my my first equation. I know that means I'm going to have a minus and a positive numbers, or positive and minus. That will give us a minus answer when we times them. So I need to find the factors of 2 now. So I know 2 is a prime number, so I know it's going to just be 2 and 1. So now I need to use this information to find out what b and a is in this equation. So I know I can put in 2 lots of minus 2 plus a plus 1 equals minus 3, because that will give us minus 4. This will be plus 1 equals minus 3. So that satisfies the first equation, this green equation. And then we can just do minus 2 times 1, and we know that equals minus 2. And so that satisfies the red top equation. Great, so we know to factorize this, we can have 2x. Our b value is minus 2. So I'll just write it down here. So b equals minus 2, a equals 1. So we know that we're going to have plus 1, 2x plus 1. And we're going to have x minus 2 equals 0. So now what we're going to do is find out what x has to equal for this bracket to equal 0. So here we go. We're going to have x equals minus a half for the first one. And basically what this is saying is when we put minus a half into as x, this bracket will equal 0. So this whole bracket will equal 0. And then our whole equation will equal 0. And then if we did the same for this one, so that will is x when x equals positive 2. So if I was to put x equals 2 into this bracket, I'm going to have 0, and the whole thing will then equal 0, because it will be 0 times anything times 0 is going to be 0. Okay, so I've now got my two terms. So x equals minus a half and x equals 2. A few lines upwards, I said let x equal sine theta. So now I'm just going to reverse that. I'm going to put sine theta back in for my x. So I know sine theta equals minus a half or 2. Okay, so now we have a slight problem here with this 2. We know our maximum values of sine theta is going to be 1. So 2 isn't a solution, so we're not going to get a number for when sine theta equals 2. And we'll have to draw out the graph. So we'll draw out the graph now, because we're going to have to do it eventually. So I'll draw it out. And if I was to start drawing the sine graph, so sine theta, we know the maximum value here is 1, and we know the minimum value is minus 1, and we know this will be 0. And what we're going to do is put our important points, which are 90, 180, 270, and 360 about here. Here we go. And so we can draw it. So we know that it starts from the origin. It peaks at 90, comes back down to 180, and then is the greatest trough at 270, and then back up to 360. And that's just sine graph, so that's sine theta. So we know we're not going to have sine theta equals 2, so that is not a solution. So here we go, so we're just going to work with our minus a half. So I'm going to rearrange and get theta equals sine minus 1 minus a half. And when you put that into a calculator, you should get minus 30 degrees. We need to be careful here because we're only looking between 0 and 360 degrees. And minus 30 degrees isn't within our range. But what we know with our sine and cos graph is that it repeats every 360 degrees. So if we have a minus 30 degrees, we know we're going to have another point in 360 degrees time. So we can have minus 30 plus 360, which will be 330. So we have a point between 0 and 360 at 330 degrees. And so I'll put that on a graph, and that's about here, this little bit. And if we project that down, it's about here on the graph. Okay, and so what we now need to do is project this line across the x-axis, like so. It's a bit off. I'll try and move it up. That's a bit closer. And what we're going to do, where it hits the graph and it comes back up to the graph, and this is how we're going to find our angle. So for these types of questions, I know that I have like a line of symmetry at 270 degrees. There's many ways to work out this second theta value, but this is the way I like to do it. And I know there's one at 90 degrees. So these lines of symmetry. So I know I have my point here is 330 degrees. And I know that from 270 to 330 is a 60 degree difference. So the difference between 330 and 270 is 60 degrees. And because I have a line of symmetry here at 270, I'm going to be 60 degrees going in the opposite direction. So that means I have 60 degrees less than 270 degrees, which this means that this will be 270 minus 60 degrees, which will just give us 210 degrees. So I've now found that my theta values between 0 and 360 degrees equal, so theta equals 210 degrees and 330 degrees. Great. Hi guys, if you found this video useful, please consider liking and subscribing. All written notes will be available in the description. Best of luck with all your exams, and I'll see you in the next one.